Okay, so level order traversal. Got it.
Yeah. Just gonna look at this. Yeah, go ahead. I'm typing.
Okay, so that's it. Just a level order traversal here.
Yeah. You don't need to.
Okay.
You don't need to take care of null pointer.
Right. So a level order traversal is kind of like a breadth first search kind of idea. And in order to do that, I would use like a queue to iterate through things. So level order traversal.
Okay.
Okay. So I shall do this in Python. Okay, so let's get a queue. Actually, somewhat just recently learned this library queue. I just used a list before, but this is actually optimized in Python.
Okay.
Right. So let us put the first element on it, which is root.val. Okay. And then, right, we need a res, a results. Okay. So I'll keep this as just this for now. So while the queue is not empty. Oh wait, you could just do this in Python actually. Don't need these parentheses in Python. No more C++. Okay, so while the queue has stuff on it, okay, so I kind of need a temporary queue or like a next queue, next level queue, so that I don't mix up which things on which level.
Okay.
Because yeah, like when I put the children of this node on here, I don't want to put it on this queue necessarily.
I see.
Yep. So let's do queue.get. This is like pop, and it actually pops the element off. So let's call it node. So we actually popped it off, and then in the next, okay, so I think it should go, these are just values, right? Okay. So we could append to the, okay, interesting. So while queue, okay, I'm not sure exactly. I'll think about how to put this on in a second. I'm just thinking of something a bit more pressing. So, okay, so if node dot write, then let's append, or no, put, this is the queue. So let's put the, let's put the node dot right over there. If node dot left, let's do the same for that. And then like the thought that I had that I really wanted to get down was that if the queue is empty now.
Mm-hmm.
I want to say Q can get the next level Q next.
Okay.
Yep. Because I was either going to have to do some kind of double loop or something, but the idea is that like we'll just keep going through the queue, whatever, and then at this point, and like when we go through the queue, we'll add all of the children onto the next level queue, and then when there's nothing in the queue, then we do that. We make the queue equal the next level queue and clear the next level queue. And so what I want to do here now I know better what to do. So not res, let's make it at -1, because here I'm gonna like append another row. And then here I'm always putting it on the back row, the value.
Okay.
Yep, so this is how I'm keeping track of that.
I see. Okay, but what would happen if you reach the last row?
Yeah, that's a good question. So, okay, so the queue is now holding these values, and so the 15 doesn't have any left or right nodes. It goes through back to the while queue. Now, does the 7 have any right or left nodes? And it doesn't. So now the queue is actually empty. And yeah, next level queue is also empty. Okay, so we have an issue here. Okay, so I guess let's just do this the simplest way. So if queue is still empty here, or sorry, if there is still a queue to go through, right. Yeah, you're right. That was a good edge case there. Or not really an edge case, but like, yeah.
Okay.
Yeah. Okay, so do you want me to walk through this again, or?
Yeah, and the other thing is, I think you want to switch the order that you push the.
Yes. Yep. Yeah, and I was just thinking of something like, will the order within like a long span of nodes, or like a tree that's gotten pretty wide, will all of those go from left to right? And I think they will, because the leftmost thing is pushed on the queue first.
Okay.
Especially because of this thing here.
Okay.
Yeah. The left is always pushed before the right in the queue.
Okay.
Yeah. So to go through it, so the idea is we have like a current queue and a next level queue, because we want to preserve levels. We don't want to push the children onto the current queue.
Mm-hmm.
This is our result. So the idea is to, so you first, this is going through our first level, you could think of it, or the current level. And so you pop the node, get it, and then you put that value on. So in this case, we'd put the 3 on. Now the 3, yep.
Okay, that makes sense.
3 has 2 children, and they both get put on the next level in the left to right order.
Mm-hmm.
Now the queue is empty because it was just 3, so we this is an O of 1 step, I think. Well, actually, we might want to copy this. I
don't know. That's Python just like
R
variables stored as pointers, like
yeah,
those names.
it is. It's probably you have to do your copy. Yeah, it's a reference, and then this clears it. But
Okay,
this whole thing would still be O of n. Technically, every node at one point is moved, or it's not even, yeah, but technically it's pointers to nodes, so yeah, I would still classify this as O of n.
Okay.
Mm-hmm.
I think you're missing the edge case where root is a null.
Yes. Yep. Okay, so yep, that's a classic one. So I guess there's not much to do if it's, well, actually, oh yeah. Yeah. Return probably that. Okay, actually, this should be a not. Yeah, so what about the one when there's just a root here? Does that work out? So you put single value on here, go through it, whatever, there's nothing being put on because there's only one element. That means the queue is going to update to nothing, and then it's going to return just that one. Yeah.
Okay. Okay, looks good.